In this presentation, we will learn about variable size, range, declaration, and initialization in Java. As we have discussed the data types in the previous presentation, the data types for storing whole numbers are byte, for performing the bitwise operation, with the size 8 bits, short, for performing the smaller range of operation, with the size 16 bits, int, for performing a wide range of operation, with the size 32 bits, long, for performing the longer range of operation, with the size 64 bits. In each case, the first bit is used for storing the sign magnitude. In this case, the range of each data type is determined by its number of bits. Hence, for n number of bits, the range of integer extends from -2 to the power n minus 1 to 2 to the power n minus 1 minus 1. For decimal point representation, we have float. It is used for storing a small range of decimal values, with a size of 32 bits. Double. It is used for storing a wide range of decimal values, with a size of 64 bits. In this case, also the first bit is used for storing the magnitude. The range of this floating point representation can be calculated from IEEE Standard 750 for floating point representation. This is beyond the scope of the syllabus, but if you are interested in it, check out the link given below. Moreover, the range of these data types is given below. The difference between these data types is: float calculates the value up to 6 significant digits. Double calculates the value up to 15 significant digits, as it includes double precision. For alphanumeric representation, we have char. It is used for storing a single alphanumeric character, with a size of 16 bits. String. It is used for storing one or more combination of alphanumeric character, with a size of more than 16 bits, depending on the size. The alphanumeric values follow the American Standard Code for information interchange. The ASCII code for letters and numbers are given below. For convenience, we can interconvert uppercase and lowercase by adding 32 and vice versa. Boolean is a specially designed data types in Java. Its value can either be true or false, and its size is just 1 bit. Moreover, if any value is not assigned, then the default value of Boolean is false. Now one might think about how to differentiate char, string, and Boolean. That is mainly string and Boolean. Char is usually enclosed within a single quote. The string is mainly enclosed within the double quote, and Boolean has no quotes around true and false. Now, we shall discuss how to declare a valid variable in Java. Let us consider an example. Int value equals 108. Let us summarize what we have learned. Int is a data type, value is a variable, equals sign is an assignment operator, 108 is a constant, and semicolon is a punctuator. So for valid declaration, the data type and the constant value assigned to it should be compatible. That is, specific data type should be assigned to a specific constant and it should lie within the range. In the example below, as char store only one character, so the first declaration is wrong. Similarly, for another case, as the short store only a smaller range of integer, hence it is invalid. Other criteria are: the declaration must end with a semicolon. For multiple declarations, we can use a comma between each variable. Equals operator must be used strictly. The most important is that a valid name should be given to the variable. Before learning the rules for naming a valid variable, let us consider an example. For instance, the memory for running the program is divided into many major components. The basic components are reserved words, instruction, and data. So whatever declaration we made is passed in the form of instruction, then the compiler fetches the reserved words and characters, and assigns the values in the data at a particular address in the memory. Let us consider an example. The first example is invalid as the keyword int, expected non-reserved variable. In the second case, the compiler treats the space as the end, as it precedes it expects a equals operator or semicolon, but upon encountering another variable it becomes invalid. Similarly, the compiler treats numbers and other special characters as space, and if they are used in between or at the beginning the declaration would be invalid. Therefore 3 and 4 are also invalid while 5 is valid. The most important point to remember that we can use underscores as it is the only exception in a special character. Therefore examples 6 and 7 are valid. Once the declaration is valid, memory would be allocated to the data at a specific address. The different types of initializations are static initialization and dynamic initialization. In static initialization, a constant value is directly assigned to the variable, hence the value is available to the variable before the runtime of the program. The examples are given below. In dynamic initialization, a combination of variable and constant with or without operation is assigned to the variable, hence the value is available to the variable during the runtime of the program. The examples are given below. Please solve the question given below to make your understanding crystal clear. Thank you. Hope you like this presentation.